like to welcome you all for taking the time. Thank you for taking the time to join us. This is a very very interesting topic here that's applicable to pretty much all of us in industry these days. Tank and compressor seals and venting solutions surrounding those, and the regulations that are emerging, the requirements we're all going to have to meet here in the very near future. My name is Mark Ryan. I am the VP of Engineering for the energy vertical of McIntosh Perry. Also on the line, although not visible, is Dean Michaud, our VP of Business Development and Projects. We're going to try to be facilitators. We'll try to answer some of the questions by text as you enter them in your question box. Otherwise, we'll save them all for the end, and we'll answer them at the end of the session. So without any further ado, I would like to introduce our presenter, Adrian Hedrick. Adrian is the Manager of Regulatory and Environmental Development for McIntosh Perry Energy. And she's been doing some great things with our engineering team here over the last year and a bit. So I will turn it over to you, Adrian. Take it away.
Awesome. Thank you, Mark, and thank you to everybody who came to hear our presentation today. So just to give you a little bit of an overview of what we'll be chatting about today, we'll give you a little bit of an introduction on why this topic and why we decided to do this presentation. I'll show a diagram that shows Alberta's emission sources and where our equipment today, tanks and compressor seals, play into the overall upstream oil and gas emissions within Alberta. I'll do a little bit of a detailed overview on the compressor seal venting regulations and also tank venting regulations. So I'll go over those within Alberta, BC, I'll touch on them in Saskatchewan, and then do a little bit of a federal overview as well. Then we have some information on some of the solutions that we've been actually getting the chance to go out there and apply to some of these venting problems out there. So we'll talk a lot about the solutions as well today. And then after we get through that, we will chat about some of the funding programs that can help support these projects, specifically emission reduction projects. And we'll also touch on carbon offsets and how those play into the whole support for your projects or the potential for support for your projects. And then, as Mark mentioned, we will open up the presentation for some question and answer. So we're continuing to receive a lot of comments from our clients on greenhouse gas emissions. So a lot of the questions that we're getting are with regards to the actual regulations, timelines, and reporting requirements, how they specifically apply to some of their facilities or their whole fleet of assets. People are coming to us with what are the options for methane emission reduction? And then what does that look like in terms of cost? And is there any financial support to help us push these projects along? Not all of them are cheap solutions, although some aren't too expensive, but not all of them are cheap solutions. And so it's great that we do have some funding options still open, incentive programs, and also carbon offsets to help support these projects. So looking at Alberta's upstream oil and gas emission breakdown by sources. The areas that we're talking about today, as I mentioned, we're going to be talking about tanks, which make up about 19% of Alberta's upstream oil and gas emissions. And then we're also going to be talking about compressor seals, which make up 6%. So 25% of Alberta's oil and gas, upstream oil and gas emissions will be the topics for today. If you happen to miss my last presentation, it was on pneumatics. And some of the solutions around pneumatics. And so that one, we did that one a couple of months ago, and it is available on our website. So that one makes up 22% of upstream oil and gas methane emission sources. And just to note, this figure is taken from PTAC, and I think it's about a year old. So potentially the numbers have shifted a little bit, as obviously in the last year, a lot of people have been undertaking projects at their facilities to reduce their emissions. So getting right into compressor seal venting. So both reciprocating and centrifugal compressors drive natural gas containing methane. These compressors have dynamic seals that wear and start to vent natural gas as a part of their normal operations. For our reciprocating compressors, this includes the piston rod packing vents, drains, and the distance piece vents and drains, including the purge system vents. And for compressors with wet seals, so those that use lubrication oil to run, these ones are especially prone to venting higher amounts of methane, and that's just as a part of their regular operations. Then in order to avoid equipment damage in sour service, pressurized purge gas is used to force directional leakage where gas can be captured. So as I mentioned, these aren't huge emission sources at your facility. They're about 6% of overall emission sources. And I will note that this doesn't include any emissions that are caused from the compressor engine, so the combustion itself that's taking place. Also, the gas emitted from the crankcase of a controlled reciprocating compressor is considered a fugitive emission and also not included within the limits that I'm about to go over on the next few slides, as well as the vent gas from engine and turbine starts. Blowdowns, that's all managed under the overall facility venting gas limit. So again, that's not included with the compressor seal venting regulation limits. So now, as we actually look at these limits, I'm not going to necessarily run through each of these actual numbers per type of compressor and per date, but what's important to note here is that all of the compressor limits within Alberta come into effect for January 1st, 2022. And these emission limits apply to compressors that are rated for at least 75 kilowatts and are running at least 450 hours per year. So, I mean, that's not a lot of time. That's only about 18 to 19 days of running time. And in addition to these limits, I guess really the way you're confirming whether you're hitting these targets or not is within Alberta, you do have to test your compressor seals for their emissions every 9,000 hours that those compressors are pressurized. So that works out to approximately once a year. And then if you do find that you're exceeding the emissions for that compressor, then the operator has 30 days to bring that compressor within compliance. Within British Columbia, fairly similar. They always kind of break down the difference between reciprocating and centrifugal compressors as far as what the limits look like. One of the major differences, I guess, in BC is just that some of these regulations are already in effect as of January 1st, 2021. And then for some of the existing compressors, so anything installed prior to January 1st, 2021, their limits come into effect as of January 1st, 2022. And I mean, I think it's one thing that's really interesting to note with BC's as well is that they're basically just saying all new compressors that have more than 4 throws for reciprocating compressors must route all emissions to gas conservation equipment or flare. So they don't really give you an emission limit there. They just don't want venting to occur out of those compressors at all. Now, when we're looking at this from a federal standpoint, again, they have their various limits listed depending on whether it's existing or new compressors, as well as whether they're centrifugal or reciprocating. So similar to the provincial requirements. One of the biggest differences at the federal level is that these are all come into effect January 1st, 2023. So they kind of give an extra a year there to come into compliance. And I think that's mainly because the federal emission regulations apply to facilities that are federally regulated. So those are the facilities that are regulated by the Canadian Energy Regulator, formerly NEB. So in a lot of cases, these are large compression sites on major transmission pipelines and stuff like that. So the compressors are quite a bit larger, and it is more likely that they are going to be venting at a little bit higher rates than some of the typical upstream oil and gas facilities will be. And just like within the provincial regulations, the compressor seals do need to be checked once a year to determine compliance with your emission rates. So I'll chat a little bit about the tank venting now, and then after I finish that up, I'll go into the solutions for both, because in a lot of cases, the solutions are quite similar for tank venting and also compressor seal venting. So your typical oil and gas facilities are going to contain a number of storage tanks that typically do vent or leak emissions. So you're looking at oil storage tanks, condensate storage, raw produced water, waste products, waste product storage, and the volume is really quite variable depending on the flow rates and the type of operations that are going on at that facility. And where you're actually getting the venting occurring from these tanks is due to displacement of production fluids through loading and filling, the flashing of the stored fluid, and breathing of your tanks. Really, it's just a part of the natural operations at most facilities that these tanks are going to be venting some emissions. And we're finding, based on a lot of the data that's coming back from a lot of the fugitive emission studies and other emission studies and measurements that are going on in the field, that the tanks are definitely the highest emitters out there, and therefore one of the areas that's being targeted for emission reduction. So when you're looking specifically at tank regulations, although tank venting is one of the major sources of emissions that it's counted for under the overall vent gas limit and the defined vent gas limit within Alberta, the tanks themselves don't have a specific limit in Alberta. So what we're looking at is, and just to, I guess, define the two, so your overall vent gas limit is all of your venting at a facility, both your routine and your non-routine venting, whereas your defined vent gas limit is from your routine venting. So that's kind of the major difference there as we're looking through these numbers. Your overall vent gas limit is restricted to 15,000 meters cubed per month, or 9,000 kilograms of methane per month, and that just really depends how you're estimating and measuring those emissions, and that's already in effect. So that was in effect as of January 1st, 2020. There was some exceptions to that number over the last couple of years, but now all of the venting falls under the 15,000 meters cubed per month, minus the most of the exceptions that were there initially for the first year or two. Then you're looking at your defined vent gas limit for existing sites. So this you just have to follow, you're following the above rate, kind of unless there's these exceptions. So I'm kind of going to go over these ones next. So the defined vent gas limit for new sites is actually 3,000 meters cubed per month. So again, your defined vent gas is your routine flaring or your routine venting, and you can see that that's substantially lower than your overall vent gas limit. Now you have to hit those targets as of January 1st, 2022. And your vent gas limit for new and existing crude bitumen batteries is a little bit different because you can actually, you can take all of your crude bitumen sites together as a fleet within Directive 60, and you can apply the 1,500 meters cubed per month per site as a fleet average instead. And that also comes into effect as of January 1st, 2022. And just to note, when you're talking about doing a fleet average, that's actually the average of all of their crude bitumen sites. It's not like pick and choose your fleets, which you can do in some situations for other averages. That's not the case for this one. When you're looking at tank regulations for British Columbia, they actually do have specific limits for the tanks at a facility. So these numbers are for all of the tanks at one facility. So for any tanks that began their operations, that are going to begin their operations after January 1st, 2022, they have to emit less than 1,250 meters cubed per month of vented gas, and that's for all of the tanks at their facility, and that's by January 1st, 2022. So basically any new construction or any new operation after this time, or the start of new operation after this time, has to hit this limit. Now for all existing facilities, so anything that's operating before January 1st, 2022, they have to meet the target of 9,000 meters cubed per month. So again, obviously a very substantial difference between new sites and existing sites. They're really looking for people to incorporate efficiency into their new facilities. When it comes to tank and compressor regulations within Saskatchewan, there's not specific numbers like there is within Alberta, BC, or at the federal level. In Saskatchewan, only oil facilities are regulated under the oil and gas emission management regulations, and the tank venting is still definitely a substantial, as it is most places, the tank venting is a really substantial source of emissions at facilities within Saskatchewan, and reducing your tank venting is one of the highest impact ways to reduce your compliance costs under the output-based system that they have within Saskatchewan. Now, at a federal level, again, this is very similar to Alberta, where there's not specific venting limits for each individual tank or for a group of tanks, but where the tank venting is basically the biggest source of contribution to the overall venting at a facility. So for federally regulated facilities, they can't exceed 15,000 meters cubed per year from all of their sources. And just to kind of highlight that, within Alberta, just to remind you, it's 15,000 meters cubed per month. So federally regulated facilities have a much lower emission threshold than provincially regulated ones do. Now let's talk about some of the tank venting solutions. So when it comes to tank venting, really the biggest factor is that it has to be a site-specific solution when it comes to tank venting. There's so many variables at a facility that really play into what the best solution for reducing the venting at that facility is going to look like. So you have to consider your geographical location, your access to utilities, what other existing equipment and instrumentation you have at the site and what it's run off of, and also just the overall volumes, like how much are you venting at that facility and how much can you potentially capture or burn or conserve. So consideration to all of these factors will really help you match what the appropriate a solution will be for that site. So what I have here is in the darker orange, some of the site factors or considerations that you have to make when you're looking at tank venting. And then on the right, I have some of the proposed solutions. And note that some of these might happen in parallel or with each other. And there's some unique situations where, you can either combine these or maybe we have to come up with something a little bit more unique or different altogether. But one of the main things to consider when you're looking at what your solution will be is what is your proximity to a natural gas pipeline or a gathering system. Conserving that gas is always one of the preferred ways to deal with vented natural gas. So are you close enough that you can tie into another system? And if you are, let's get a vapor recovery unit going for you there. What is your existing facility energy usage? So there's also the potential to use that wasted gas at the site for repurposing to run on-site instrumentation or fuel gas supplementation. Then there's also looking at your overall facility footprint. What does your spacing look like? Do you have some flexibility? Can you fit in clean combustion, incineration, or flaring at your facility? Often that's the solution that a lot of people are turning to. Especially the clean combustion and incineration has really picked up in the last year in trying to get kind of some of those smaller sources of vented gas down. When you're looking at your existing instrumentation, what are you doing for existing instrumentation at the facility? There is the potential to use some of this vented natural gas for power generation and instrument air conversion as well. So that's something that can be looked at. And then, do you have a local utility or what are your on-site electrical requirements? We're seeing a ton of interest and a lot of people are picking up on interest of using waste gas to do power generation, and whether that generated power is going to be running the facility itself or whether they potentially even want to tie it back into the grid or partner with somebody else to be using that, to be using the power that's generated are all options for tank venting. Now, when we're talking about compressor seal solutions, a lot of the solutions are similar to tank venting, but one of the major differences is that with compressor seals, the maintenance regime is also really important. So just making sure that you're replacing those seals more frequently can be the way to get your emissions within the limits that we've stated. I actually did participate in a study just prior actually to coming on to Macintosh Perry, where we analyzed the leakage rates from compressor seals from thousands of compressors across Canada. And what it showed was that although the manufacturers might state that you only need to replace the seal every 5 or 10 years or whatever's in their kind of warranty, we're finding that initially for the first couple of years, the seals weren't leaking beyond the emission rates that we have listed within the regulations. However, after about 4 to 5 years, they usually were. So in some cases, you may not have to replace the seal for 10 years, but replacing it more frequently may bring you down to venting enough or a low enough amount of methane that you can at least keep it within the limits. New seals also do have a bit of a break-in period, so they require due care and attention from operators and mechanics to just confirm how much they are venting during that period, and then they do require continued monitoring. And then one of the other, the major way that you're going to be stopping your emissions from compressor seals is capturing it. So installing distance piece, seal pot, and vent capture systems. So this is already typical on sour gas systems, but it can also be easily installed on sweet systems as well. So capturing all of your natural gas and then repurposing it, very similar to what we were talking about on the previous slide. So whether that's repurposing it for use at the facility, or whether it's repurposing it to get it to a source of combustion. So whether that's an incinerator or a flare. One thing that I am seeing that's fairly common is these small portable combustors that can really handle a very small amount of vented natural gas. And they're just smaller units that are actually even portable and can be moved from site to site. They have reduced spacing requirements. So I'm seeing that being a really popular, common option to deal with compressor seals that are not due for any maintenance. There's no plan to replace them anytime soon. Just kind of a quick solution to deal with the vented methane in the meantime until maybe a more detailed solution can be looked at a future date. We're also seeing, I should note that we're also seeing that the manufacturers of a lot of these compression units are actually also coming up with a secondary seal system where they're containing the gas, and these can be added to existing compressors, or they can also be purchased with new compressors, and they're kind of just in the works of getting them a little bit more readily available. But again, that's mainly going to help you capture the gas, but then what you do with the gas once it's captured, there's lots of different ways to utilize that. So now that we've talked about the regulations, some of the solutions or the ways to reduce your emissions at these facilities, I'll talk a little bit about what are some of the incentive funding programs that are still available that can help you fund these types of projects. So the first one that I'm going to talk about today is the Methane Technology and Implementation Program. So this program actually just celebrated its, I think, 1-year anniversary this last month. And the funding is still allocated on a first come, first served basis. And the way it works is they'll fund up to 50% of your project costs, but there is a maximum of $1 million per owner, and a minimum project cost or a minimum project payout of $10,000. So they do want your project cost to be at least $20,000. This program is stackable with other funding options such as ERF, which I'll talk about in a couple of slides. And one thing to note about this one is you do have to follow an eligible protocol. So I will show you the eligible protocols or project types on the next slide. And although I do mention that this program is stackable with ERF, I will very specifically note that if you are accepting MTIP funding, you cannot also generate carbon offsets. Now that's for the specific project, not like for that company as a whole or even for the facility as a whole. But if you are doing a pneumatic replacement on one type of device, that same device cannot be double counted for a carbon offset as well. It is one or the other. And I will note that when they just kind of had they announced their 1-year anniversary this last month, they specifically mentioned that only 53% of their funding had been promised to projects thus far. So there's still lots of potential to get some projects in the door with MTIP and get some projects funded through them. So that's some of the eligible project types. So these all have very specific greenhouse gas quantification protocols and methodologies for doing the calculations that need to be submitted to MTIP. Now, just because your project isn't on this eligible project type list, if you have an idea for something else that will substantially reduce specifically methane, but emissions in general at your facility, you can always propose it to MTIP. They do have a separate process for going through that you can do. That where you propose your technology up front, they approve that first, and then you can go through the rest of the application process. But the approved project types are, so under pneumatic devices, electrifying your pneumatic devices, converting from high bleed to low bleed, from instrument gas to instrument air, and then also capturing that gas for repurposing or for combustion. For hydrocarbon storage tanks, again, you can destruct the venting from a hydrocarbon storage tank in a clean combustor. You can add a VRU, so any conservation of that gas is obviously can fall under that category. And then you can also, so they call it hydrocarbon tank destruction elimination, which basically is going from, if you're already flaring at your site, but you'd rather conserve by adding a VRU, you can actually do that as well and get some funding through this program for that. As far as compressors go, compressor vent gas capture and repurposing or utilization, compressor vent gas conservation, so tying that into an existing VRU system or something like that at the facility, and then compressor destruction emission elimination, so basically that clean combustion of your compressor emissions. And then they also have a couple of less common ones. They did just add the casing gas destruction and conservation, which they didn't have previously. Those were added in the last couple of months to their eligible projects. And then they also have vent gas reduction from desanding and surface casing vent gas flow and migration. So those are all eligible project types within the MTIP program. And I will just note that we have had quite a bit of success with this program. It's fairly straightforward in that they give you all the quantification methodologies to use. You know, I'd say one of the caveats is that they do want your project completed within 6 months of getting approval from them. So you do have to have your project fairly scoped out and really ready to go before applying to MTIP, because they do give you a 6-month time frame to finish your project. But we've definitely seen lots of people have success specifically on the VRUs and then some of the pneumatic devices and compressor seal projects as well. So talking about the Emission Reduction Fund. So this fund has also been out for right around a year as well, I believe. This one's delivered through Natural Resources Canada, and it was a $675 million fund when it first came out. They haven't specifically noted how much of that is left, but they have had 2 previous intakes for this program. So what's going on right now is their 3rd intake. They recently opened their 3rd intake. The way this program works is they will fund up to 75% of your project costs, but the funding comes in the form of an interest-free loan. Now, the key with this is if you just choose to accept an interest-free loan from ERF, then you can actually pair that or partner that with carbon offsets. However, if you choose to have any portion of your loan forgiven, so basically it becomes a portion of your loan is a grant, then you can't claim any carbon offsets. So I do want to note that right there. But when talking about a portion of your loan getting forgiven, this is one of the biggest changes that they made in this 3rd intake. They really increased the amount of the loan that could be forgiven. So it started off as about a 10 to 50% of your project could potentially be forgiven. And that's for when you do eliminate emissions, I should say. So it's not just going from, let's say, venting to flaring. It would be going from venting to conservation or flaring to conservation. So by actually eliminating an emission source, you can get a percentage of your loan forgiven. And they've upped that percentage to 40 to 80% of the total loan. So that's quite a bit higher than it was in previous intakes. And I think it might potentially interest a lot more people than it did previously, because when we did the economics previously for a lot of projects, it looked like they were only going to get about 10 to 20% of the loan forgiven. So I think these numbers might interest a lot more people in the ERF program going forward. In addition, they are looking for bigger projects. So the ERF program is looking for, they want to minimally fund you $100,000, and the maximum was actually just increased again in this 3rd intake to $50 million per company. So it started off at 20, they increased it to 40 in the 2nd intake, and now they've actually increased it all the way up to $50 million. And so that's obviously a substantial amount of money. And we've seen a lot of success with clients putting projects through, such as like gas gathering systems. So for a bunch of facilities that had a lot of stranded gas, it was not economical to build a gas gathering system. We've seen a few people use this program to fund that and conserve high volumes of natural gas within a whole field, so kind of coming off of a bunch of different sites. And then we've seen success on smaller projects too, a lot of VRU installations or compressor seals tied with pneumatics, tied with VRUs, stuff like that. So lots of different projects that we've seen get an approval through the ERF fund. And just the dates for this third intake period. So it is currently open, and the application period closes on January 7th, 2022. And the eligible expense period for projects. So this is really when they're expecting you to be getting invoices, start making purchases, start your detailed engineering, is April 1st, 2022 through to March 31st, 2023. The goal here being that they wanted to give everybody the chance to apply for the funding kind of at, towards the end of this year to plan their projects for next year. One of the problems that they were running into is that they were taking a while to get decisions back to clients. So clients had to move forward on their projects. And then there was a lot of wishy-washy or hesitation on how much retroactive funding could be made for some of the projects. So what they want to do is they want to give everybody a decision by March, so that by April moving forward, you actually know if your project's been approved, and then you can start spending the money. Now, there are some additional incentive programs that are out there. I won't go into them in a lot of detail, but I'll just kind of note that they're constantly changing. So it's always important whenever a client chats with me about the potential for either a really innovative project or something that's maybe more mainstream, but anything that will have a significant or just an impact on emission reduction. I always kind of go through a few different areas to make sure that there's no new funding that I can see coming up, or that there's no challenges going on. So Emission Reduction Alberta and CRIN, Clean Resource Innovation Network, regularly hold challenges. They do currently have, so Emission Reduction Alberta does have an energy efficiency for business program going on right now. And some of those protocols apply a little bit to oil and gas, but they're not as direct of an application of some of their previous programs. However, we can still look at that if that's of interest. And then Alberta Innovates is another one. They're constantly holding challenges, more on the innovation side. So as the name kind of sounds, Alberta Innovates, they're looking for innovative projects and kind of to fund anywhere from that initial research and innovation stage into actually piloting new projects. Clean BC Innovation. So each year BC they kind of open up a few different incentive programs in the spring that are aimed at emission reduction and innovation within the oil and gas industry. And then they usually close a few months after and reopen the following year. So there aren't any open right now. However, they probably will open up again in the new year. And then Saskatchewan also does have some royalty credit programs that are aimed both at just oil and gas development in general, and then also innovation. And I think that most people that are working within Saskatchewan are utilizing these to some extent, but if not, that's definitely something I can provide more information on as well. So, we were talking about a bunch of the different incentive funding, and one thing that we can't miss when we're talking about financial support for our projects is to look a little bit at carbon offsets. So one of the major things with carbon offsets is that within the Alberta carbon offset market, the way it works is you can only generate an offset for a 1 ton of CO2 equivalent if it's kind of going above and beyond what the regulations are requiring you to do. So there's often, currently right now with new regulations coming into effect, there's often timelines that are involved. We're acting sooner. Sooner than later will get you more carbon credits than waiting. But one of the new draft protocols that has come out that's really related specifically to the topics that we've been talking about today is, I think they actually just renamed it. So it was solution gas conservation. That's what everyone's kind of been referring to it as for the last year or two, but I think it's actually now called vent gas reduction. And that was just released in June. So a draft of that was released in June for comments. Comments were expected to be finalized in August 2021, and that final protocol is expected in this fourth quarter. So anytime we could see a final protocol of that vent gas reduction protocol, to come out, and that protocol allows you to do the quantification listed within that in order to be able to generate offsets to be sold on the Alberta carbon market. And so when it comes to venting, it's going to apply to emissions that are under 500 meters cubed per day at your facility, because anything over that, the regulations require you to do something with that anyways. So from 500 meters cubed to 0 is basically that space where you can potentially generate carbon offsets for conserving vented gas at facilities. So, and just for those of you who aren't super familiar with the market, 1 ton of carbon dioxide equivalent is equal to 1 carbon offset, which was $40 in 2021. However, with the Liberal government remaining in power, getting in power in this last election here that just happened, you know, it's much more likely that we're going to see that exponential growth that they were stating that we're going to have. So potentially up to $170 a ton by 2030, which definitely makes, I mean, already our carbon offset market is quite lucrative within Alberta, but obviously the Alberta offset market cost per ton will follow the federal price for carbon, and so it's expected that these projects will just get that much more lucrative going forward. So carbon offsets is somewhere that we are working in as well right now, and we're supporting our clients in getting their offsets on the Alberta offset market. So if that's something that you have questions on, or if you want like a cost comparison between doing carbon offsets versus accepting some funding from some of the other programs, that's an area that we're working a lot on as well, just kind of helping with the underlying strategy of what works best for a specific situation, whether that's a specific facility or an entire fleet. That's an area that we're really supporting a lot of people in right now. And that's what I have for a presentation for today.